Alright guys, these are our last notes of the year, which is super exciting. Okay? So, factoring day 3. This is factoring when trinomials when a is not 1. So, we're warming up here, multiplying the binomials by foiling. So if we foil, that would be 2x times x, which would give us 2x squared, 2x times 4, which would give us plus 8x, negative 3 times x, which would give us negative 3x, and then negative 3 times 4, which would give us negative 12. When we simplify, we would get 2x squared plus 5x minus 12. And then that's because the 8 minus 3 becomes 5. So hopefully we remember how to FOIL. But looking at that is going to show us where the factoring comes from, okay? And there's two really neat ways to do this factoring. So the first way, or method, is sort of like a guess and check, okay? We're basically going to take this 2x, and now we're going to have to split it up so that 2x is in one of them, and then just x is in the other, so that when we multiply 2x times x, we would get 2x squared. So this is kind of the guess and check method, okay? So we have 2x squared, we have x, negative is here, so that means one's going to be positive, the other is going to be negative, or the first one could be negative and the second one could be positive, okay? And then we need to get a 12. Well, the only ways to get a 12 are 1 and 12, 2 and 6, 4 and 3, okay? And then we need a positive 5 in the middle. So if you kind of just guessing and checking, say, well, we need 12 at the end, so let's try to use, I don't know, 6, because 6 times 2, that's 12, that's a little big. But 2 times 2, so if we did a 2 right here, that would be 2 times 2, which would give us 4x. And then we'd have to put a 6 here, that would give us a 6x. And then it could either be negative 4 and positive 6, or it could be negative 6 and positive 4. It doesn't look like either way we're going to get a 5x out of that. So it looks like 6 and 2 are not our options that we need there. So let's try a different combination. Let's say 3 and 4. So what if we did 3 here and 4 here? Well, then that would give us 3 times 2, which is 6x. That would give us 4 times x, which would give us 4x. Well, that looks like it gave us the exact same thing we just had. So maybe that's not right. But what happens if we would flip these? Well, let's put 3 here and 4 here. Well, if we multiplied those two together, it would give us 8x. Because 2 times 4 is 8. 3 times x would give us 3x. Okay, well, it looks like if we had positive 8x and then negative 3x, that would give us our answer. So it looks like we have a negative here, so it's going to be 2x minus 3. And then it looks like we need a positive 8x, so then we're going to have x plus 4 on the other side. And then that would give us that positive 5x in the middle. Does that match what we FOILed earlier? So 2x minus 3, which is good, and then x plus 4, which is good. Okay? So that is your guess and check method. And really, guys, it's just plugging in numbers and seeing if they work. Okay? I'm going to show you the other method that is a little bit less guess and check. I mean, there's still some factoring that you have to do, but it makes it sometimes a touch easier. Sometimes it makes it a longer question. Maybe you're really good at foiling. But either way, this is the second method. This method requires you to move the 3 to the end here via multiplication. So we're going to multiply this 3 into this 5. So we're going to take the 3 off of there, so x squared minus 2x minus 15. And then we're just going to factor like normal. There should be a way that this would factor out. So 15 is 1 and 15, 3 and 5. Well, it looks like 3 and 5 are going to make negative 2, right? So we need negative 5, positive 3, 2x is here. Okay, so from here, remember, at the very beginning we multiplied by 3, so now what we have to do is we have to divide by 3. And what do we divide? The last term in each factor, because we multiplied the last term in the original equation. So we divide by 3 here, divide by 3 here. That's going to give us x plus 1 multiplied by x minus 5/3. Okay, so 3 divided by 3 gives us 1. 5 divided by 3 gives us 5/3. Every single time you do this, one of these terms is going to have a fat fraction in it. So then to get rid of that fraction, what we do is we just multiply this singular term by 3. So we do 3 here, and we do 3 there. So our final answer is x plus 1 multiplied by 3x minus 5, because 5/3 times 3, the 3's cancel, and we're left with just 5. And then this should be our answer. We can always double check by foiling out, so that's 3x squared plus 3x minus 5x minus 15. So that gives us 3x squared minus 2x minus 15, which I believe was our original equation. Okay. So let's work through that method one more time so you can see it. Okay? So this time we have a 2 out front. We take that 2 and we multiply it by the last term. So it becomes x squared plus 3x minus 18. Because we took 9, multiplied it by 2, it became 18. From here we do our normal factoring. Okay, so we have x and we have x because now there's no a value. And then we need factors of 18. 1 and 18, 2 and 9, 3 and 6, and that's it. It looks like 3 and 6 can make a positive 3, so we're going plus, minus, and then it's going to be minus 3, positive 6. And then just like we did in the last one where we divided by 3, this time, because we multiplied by 2 at the beginning of this question, we're going to divide these terms by 2. So then it becomes x plus 3 multiplied by x minus 3 halves. And then the one with the fraction in it, that's the one that we take and we multiply to get rid of the fraction. So there's a 2 in the bottom, so we multiply by 2. And that's going to give us x plus 3 multiplied by 2x minus 3. Bada bing, bada boom. That is your answer. Okay? So that is how you're going to factor when a, the a value, is not equal to 1. Okay? If you have any questions, guys, please come to office hours. I'm in there from 11 to 2 every day, and it would be great to see your guys' smiling faces or frowning faces. It'd just be great to see you guys. But yeah, I hope you guys have a great last week of school.